For over 10 million years, a relic from the dawn of the galaxy drifted in silence. This ancient interstellar object, untouched by any star, wandered through the deep, cold void. Then, suddenly, as it hurtled past our sun, it erupted. This was 3I Atlas, a pristine world supercharged by a solar shockwave, now ejecting vast clouds of chemicals and dust. Scientists are now asking a breathtaking question. Is Earth about to encounter matter carrying the very origins of life? What triggered this cosmic awakening? And just how close are we to witnessing a discovery that could reshape our understanding of life itself? 3I Atlas began its journey billions of years ago, likely forged in the distant outskirts of a long-lost star system. Its incredible age, estimated between 3 and 11 billion years, places its birth in an era when our own Milky Way was still young. For at least the last 10 million years, this object has been a true loner, wandering through the galaxy without ever passing close to a star. This extraordinary isolation isn't just a guess. It's confirmed by precise star catalog analysis, tracing its path far from any stellar encounter. Throughout this immense journey, 3I Atlas drifted through the cold, dark reaches of interstellar space. The result? A surface crust enriched with ices, organics, and radiation-altered compounds, a layer that grew thicker and thicker as the object aged. This crust acts as a chemical archive, preserving both the products of cosmic ray processing and the raw ingredients gathered from ancient molecular clouds. And deep beneath this protective layer, more pristine materials remained untouched, locked away from the harsh radiation of space. By the time 3I Atlas finally entered our solar system, it was a time capsule, carrying billions of years of chemistry, dormant, and waiting for a new source of energy to awaken its potential. As 3I Atlas approached the sun, its environment changed in an instant. After eons of experiencing only a faint trickle of cosmic rays, it was about to get a shock to its system. Nearing its closest point to the sun, the solar energy it received skyrocketed. At its closest approach on October 29th, just inside Mars's orbit, its surface was blasted with about 735 watts per square meter. Photometric tracking revealed this wasn't a localized event, but a global transformation. Those are remarkable figures for any comet, let alone an interstellar visitor. The mechanics behind this point to something incredible: a cryovolcanic worldwide surge. The object's 16-hour rotation played a crucial role here. distributing that solar energy evenly and preventing any one side from overheating or freezing. This uniform heating allowed subsurface pockets of volatile material to warm up almost in sync, building pressure across the entire surface. When that pressure finally broke through, the result wasn't just a handful of jets, but a planet-wide release of gas and dust erupting from across the nucleus. The brightness spike, sustained long after the initial activation, confirmed that 3I Atlas had transitioned from a dormant relic to a fully active outgassing body, and the material thrown outward during this surge would go on to shape the complex jets and tails observed in the following months, setting the stage for its most puzzling features. Now, jets of gas and dust arc away from 3I Atlas, stretching as far as 50,000 kilometers from its core. But these streams don't just fan out randomly. They form sharply defined, wavy filaments that twist and bend, hinting at powerful forces at work. And while most comets produce tails that point away from the sun, 3I Atlas has defied expectations. A sunward-facing jet, brighter and longer than before, has grown even as the rest of the coma fades. This anomaly has puzzled comet scientists, because solar radiation and the solar wind should push material outward, not back toward the sun. The answer may lie in the object's unusual chemistry. 3I Atlas is loaded with nickel and iron. These elements, when mixed with liquid water, can corrode into magnetite, a mineral known for its strong magnetic properties. Magnetite can generate local magnetic fields, and when combined with the plasma environment produced by the comet's outgassing, these fields can reach strengths of 30 to 50 nanotesla, sometimes spiking to 300 during solar storms. A field like that is strong enough to steer charged particles, shaping the jets and even bending them sunward against the flow of the solar wind. What we're seeing is a complex dance between plasma, dust, and magnetic fields, sculpting the comet's jets into structures rarely seen in our solar system. And this magnetic cocoon doesn't just create a visual spectacle. It may also help preserve the fragile organic molecules embedded within, shielding them as they travel through space. The recent return of samples from asteroid Bennu by the OSIRIS-REx mission has already transformed the search for life-vest building blocks in space, moving it from theory to laboratory fact. Inside Bennu's dark, carbon-rich regolith, scientists found a whole suite of organic molecules, including glucose, ribose, and a range of nucleotides that form the backbone of DNA and RNA. They cataloged 33 different amino acids, including 14 that are essential to human biology. Water was there too, locked in minerals and briny mixtures, confirming that liquid once existed on this small world. Bennu is a B-type asteroid, meaning it has been more altered by heat and is less likely to hold on to fragile organics than even more primitive object types. Yet its chemistry is incredibly rich. The implication is straightforward. If Bennu, a processed remnant from our own solar system, carries such a diverse inventory of prebiotic molecules, then 3I Atlas, whose spectral fingerprint matches the more volatile rich, organic-laden Cr carbonaceous chondrites, should be even more enriched. Spectroscopy of 3I Atlas has revealed a carbon dioxide to water ratio near 8, far above typical comets, and a carbon monoxide to water ratio of 1.65. Both are signatures of active, ongoing chemistry. Combined with the Bennu results, the evidence raises the odds that 3I Atlas is not just a carrier of water and dust, but a vessel loaded with the raw ingredients for life. The question is no longer just what 3I Atlas carries, but what it might deliver. For decades, scientists have debated whether objects like this could transfer the chemistry of life between stars. The evidence from 3I Atlas, its payload of water, organics, and complex molecules brings that debate out of theory and into the realm of observation. The object's size, somewhere between 0.3 and 5.6 kilometers across, means it's large enough to shield fragile compounds from radiation over billions of years, yet small enough to shed that material as it passes a star. The timeline is now set. Discovered on July 1, 2025, 3I Atlas reached its closest approach to the Sun on October 29. It will swing past Earth on December 19, coming within 1.8 astronomical units close by cosmic standards. But the most intriguing dates lie ahead. In March and April of 2026, Earth will cross the exact region of space where 3I Atlas released its perihelion debris. For the scientific community, this is more than a curiosity. It is a testable event. As Earth moves through the dust and organic-rich material left by this interstellar traveler, researchers will be watching for signs. Microscopic particles in the upper atmosphere, new compounds drifting down from the sky, perhaps even subtle changes in the chemistry of rain or snow. The possibility that our planet could sample material forged around another star, delivered by a visitor like 3I Atlas, transforms an abstract idea into a near-term experiment. The next chapter in the story of life's cosmic journey may be written in the months just ahead. Right now, as Earth prepares to cross the debris trail of 3I Atlas, we stand poised to witness interstellar organics mingling with our own atmosphere. It's a powerful reminder that the ingredients for life travel between the stars, that our origins are not fixed, and that the story of life may be far more cosmic than we ever imagined. Thanks for watching. If you found this as fascinating as I did, be sure to subscribe for more deep dives into the mysteries of our universe.